Here's another example of a paired t-test. Okay, so a company claims that its consumer product ratings 0 through 10 have changed from last year to this year. The table shows the company's product ratings from the same 8 consumers for last year and this year. At alpha equal 0.05, is there enough evidence to support the company's claim? Okay, now let's go ahead and set up the null and the alternative in terms of mu sub d. So the claim is that the consumer product ratings have changed. Okay, so what that means in terms of mu sub 1 and mu sub 2, okay, changed means that they're not equal to each other. So that would be mu 1 not equal to mu sub 2. Okay, so that would be the case that these are changed. Okay, so because this contains, does not contain the case of equality, this is the alternative. Okay, so this forces the null to be mu sub 1 equal to mu sub 2. Okay, so we're going to let mu sub 1 represent last year's ratings and mu sub 2 represent this year's ratings. Okay, so remember this paired t-test reduces to a single t-test on mu sub d by subtraction. So an alternative way to write this by subtraction is mu sub 1 minus mu sub 2 is equal to 0, and this is what the book calls mu sub d. Okay, so our null could be that mu sub d is equal to 0 versus mu sub d not equal to 0. Alright, so let's go ahead and get the test statistic. Okay, so remember it's the observed average difference, okay, minus the claimed difference, okay, that's going to be 0, over S sub d over the square root of n. Okay, so what we're going to need in this problem is d bar and S sub d. Now n is the number of pairs, so that's going to be 8, and I can go ahead and find d bar by putting the values, the before values in list 1, the after values in list 2, the last year values and then this year values, and then right arrow over to list 3, arrow up so list 3 is highlighted. Press enter, you'll notice that it moves your cursor down below. Okay, so my subtraction is L1 minus L2. Okay, so see, I'm telling the calculator to subtract list 2 from list 1. Okay, and remember you can get your list by pressing second and then your number keys. Okay? So after doing that, we'll have created a column of differences. So d bar will be the sample mean for this column, and S sub d will be the sample standard deviation from this column. So to get that, I'm going to press on stat, right arrow over to calc, and then I want one variable statistics, and I want to change that. If it's not already at list 3, I want to change that to list 3, and press calculate. Okay, so d bar, which is the sample mean for list 3, is -1, and S sub d is about 1.309. Okay, so my test statistic will be -1 over 1.309 over the square root of 8. Okay, so calculating that real quick. I get a t-value of about -2.161. Okay, so let's go ahead and get the critical value. Actually, there'll be 2 because this is a two-tailed test. Okay, so I'm going to go ahead and sketch a bell-shaped distribution. and put in 2 areas of rejection. Okay, and the level of significance in this problem was given to be 0.05. So I want 0.025 amount of area in each tail. Okay, so I want to go to my t-table, if I can find it. There it is. Okay, so if my sample size was 8, my degrees of freedom will be 7. So I want to read down to 7 degrees of freedom and 0.05 in 2 tails. It's kind of hard to read sometimes. Okay, so see that I've got 0.05 in 2 tails. Also, that corresponds to an area of 0.025 in 1 tail. So my critical values will be plus or minus 2.365. Now look at where our test statistic lies with respect to the critical value. Okay, we're in the fail to reject region. Okay, so the decision is to fail to reject the null hypothesis. Okay, so with respect to the claim that the mean consumer rating has changed, that claim is not supported. Okay, because remember, the claim in this particular problem is the alternative, and our decision is to fail to reject the null. Okay, so to answer the question, there is insufficient, I can spell that right, insufficient evidence to support the company's claim that the ratings have changed from last year to this year. Again, since we failed to reject the null hypothesis, it is possible that a type 2 error may have occurred. Okay, now there's a quicker way to get the standardized test statistic that I went over in this last example. Because this reduces to a single t-test by subtraction, I could go ahead and do a t-test on that list 3. So if I right arrow over to tests, select to the t-test, okay, and select summary stats. Okay, we'll see that the hypothesized difference is 0. Okay, and that's what we got using subtraction. And our sample mean is -1. It carried over the information from our one variable statistics. Okay, there's our sample size. If it wasn't in here, you could go ahead and type that in. I do want to change my direction of alternative because recall this is a two-tailed test. And press calculate. So we'll see that we get approximately the same standardized test statistic. Now doing this by hand, because I didn't carry out that standard deviation quite as far as the calculator did, there is a slight discrepancy here, but nothing that would change the decision. And then here's the corresponding p-value. Okay, so since our p-value is greater than our significance level, we're failing to reject the null hypothesis. So I know that the paired t-test is not a direct test in the calculator, but we can go ahead and use subtraction and do a t-test on that third list and get the p-value.